In this lesson, I'll discuss authentication and authentication-based attacks. So by the end of the video, you'll be able to discuss what authentication is and how it's performed, but also be able to understand what points in the authentication process are vulnerable to attack, and also discuss how user habits can introduce risk in the way that they authenticate to systems and services. Authentication. Believe it or not, there's actually an RFC written for authentication. It's 4949, and it defines the way user authentication is as a whole, how we authenticate systems, or we authenticate users or objects. And according to the RFC, the definition of authentication is the process of verifying the identity claimed by or for a system entity. So in other words, how do we verify that something is, or somebody is who they say they are? So this could be a user, this could be a system. We also call this a security principle, and that's with an AL at the end instead of an LE. Security principle with an LE would be something like use antivirus, or don't use weak passwords. But a security principle with the AL at the end is an object or a person, file, something that authenticates or is the authenticator. So it is really an object. So how can an object actually authenticate? Well, think of two-factor authentication. We'll talk about this here in a minute, but a key fob that is a two-factor authentication, it is a hardware token that provides the authentication to a system. Also passwords, if you consider passwords and how a user is an object to authenticate to a system or service, the object in this case is the security principle. Let's talk about identification or authentication steps. In identification or in authentication, we have two different steps. We have the identification step, and then we also have the verification step. The identification step presents an identifier to the system. This also could be an object, like a security principle, so a system, a file, a person, one computer to another computer. Think of something like that. Verification is the second step. Is there something that validates or verifies the identity presented or security principle presented? So we have something that needs to be identified, and we have something that is identifying, and the two that, and those two together form the authentication process. There are many different kinds of authentication systems out there. Think about all the devices that you own. Right now, if I actually had my bag with me, I have a phone. I've got a hardware token, which is my two-factor authentication. I've got my laptop. I myself am an identifier. My driver's license, for example. These are all things that present some kind of identification and authorization, which makes up the entire authentication system. So think about how many times you have to log into something today. Well, I had to authenticate into my car with my keys. I had to log into my computer. I had to present actually I went to the gym today, and I had to present my identification card there to say that yes, I could actually be there. So authentication systems come in many size, shapes, and forms, but the more common authentication systems are computers. So Windows, for example, uses credential providers in Windows 10 and on. They started introducing this around Windows 8, but Windows 10 and Windows 2016, they've completely changed the way that identification happens. So credential providers are a way for third-party companies to provide authentication mechanisms into Windows. Linux is another good example of this, where we have a shared architecture for authentication using pluggable authentication modules, or PAM. So PAM modules includes things like passwords and two-factor authentication, Kerberos, and many different other kinds of modules that allow us to have a commonality and a way to authenticate into a system. The thing we don't want to have is a bunch of authentication models out there that and identification, so that we may mess up on one portion of authentication, or we lose some part of authentication. We can see this is the case in the use of CAS, that's CAS, or single sign-on, or an authentication server from Microsoft. It's ADFS, Active Directory Federated Services. So, or I guess Shibboleth is another good example of an authentication system that takes all these providers and sticks them into one identification system, so that we can verify that one system can then verify the identity of a person. So we don't have these little authentication systems all over the place. In NIST 800-63, it provides a model for e-identification architecture. Okay? It identifies the registration, the credential insurance, and the maintenance level of an authentication system, and how we authenticate from one party to another. So it identifies the verifier, it looks at the registration authority, and you can see this on your screen now, but in further reading, you can read about the authentication model. This is the de facto standard for any federal information systems that, U.S. federal information systems that need authentication. It's based off of this model. And where we really see, you may think it's actually simple to provide authentication, but you have to think all the way from how we register a user or an object, all the way to how we authenticate that user, and how do we destroy the user as well. How do we authenticate through the entire process? Factors of identification. There are 4 different factors of identification: something that you know, something that you have, something that you are, and something that you do. So something that you know is going to be a password, it's going to be a PIN, or security questions. These are all knowledge-based, something that you know and nobody else knows. Now, the identification system or the authentication system is going to have some kind of representation of that value of something that you know, but it may not be a secured, well, it may just be the password, or it may just be the PIN, but it needs to secure that credential in some way. Something that you have includes things like smart cards and physical tokens. Something that you are might be a fingerprint reader or iris scanner. So that's something that you cannot get rid of. Maybe you can file your fingerprints off, but why in the world would you do that? That presents a representation of who you are. Iris scanner, it's very expensive to put in an iris scanner, but it is the most accurate. Okay? Something that you do includes voice pattern recognition and handwriting. Also, facial recognition as well is included in this. So some threats to something that you know. Password authentication. This comes in the form of somebody phishing your password or poor password management, key logging, for example, or other eavesdropping techniques that are designed to steal your password. Password-based attacks are also an attack against user authentication, where we can see password cracking, rainbow tables, and password storage-based attacks as well. Secret questions are easy to obtain answers. If you just look at social media and look at somebody's post, you can figure out who their favorite pet is, or where they went to high school and what their favorite mascot is, or their mother's maiden name by looking at public records. Something that you know is very easy to attack. Threats to something that you have include very, very few things. So usually they're protected by hardware and they're not easy to clone. For example, U.S. passports, they do have RFID chips in them. You can copy them. Magnetic stripes, swipe cards as well. Those are easy to copy, like credit cards, or the number is easy to copy. That's why we actually have chips now inside of them. But it is hard to duplicate. It's not hard to steal somebody's password, but it is hard to actually compromise something that you have physically. Threats to something that you are, well, the industry really isn't there yet. Many facial recognition systems are fooled actually with a printout of your face. The latest Samsung S8, for example, their facial recognition system, if you put the camera up to your face and authenticate your facial features, it's fooled with a picture of your face. So false positives or false negatives, which are even worse, are issues with something that you are. The industry has not caught up to this yet. Except in the case of some fingerprint scanners and iris scanners, those are much, much more expensive, but they do provide another level of security. We also see overall security issues: eavesdropping, replay, malware, denial of service attacks, host and client-based attacks. And it really depends on how clever you are, how we get around authentication. But the easiest one, again, to compromise is password and PIN-based attacks. It's funny, I actually saw a funny post of somebody posting all PIN, the title of the email was all bank PINs listed on this paste. And what was it? Well, they're 4-digit combinations, so it was 0 through 9,999 just in a file. It was pretty funny, but the reality is there's only 10,000 combinations of your bank card PIN or your ATM PIN.